Hi everyone, how are you? How's everything? I hope you're doing well. And today I'm going to continue telling you about the diodes. So, you remember that in the past couple of sessions we talked about the diodes. We told you what are these new components that we're talking about, and this is the most fundamental nonlinear circuit component that we're going to deal with. And today I'm going to just tell you a little bit more about them. So, any diode can operate in three different regions. It can operate in forward bias, reverse bias, or breakdown. What does it mean? Let me show it to you over here. You remembered before that I told you that this diode, it passes the voltage if we have a higher voltage on this side over this side. It means it works like a one-way street that only passes the currents that are traveling this way from the left to the right in this direction. In this case, the current can pass only towards the arrow. That's the best way to remember that in which direction is passing, towards the arrow, because the diode looks like an arrow. But not only it needs to go this way, but also in realistic cases it needs to be over 0.7 volts to turn on the diode. This 0.7 is, as I told you in the previous session, for the silicon diodes this number is 0.7. For germanium it's 0.3. For different diodes, because different diodes might have a combination of different semiconductors, so it's a number around 0.7ish, between 0.5 and 0.7. So if a current is going this way and the potential on this terminal is more than 0.7, this diode is going to turn on and work like a short circuit, look like a wire. This region is called the forward bias region, okay, in which the diode is conducting. We determine it by when V is greater than 0, this region. The reverse bias region is this region that in which the voltage on the right side is higher than the left side. It means that this V, if you look at it, is less than 0. In this case, the diode is not gonna pass. The diode is off. It's working like an open circuit. So this region, we determine it with when V is smaller than 0. But look, at the end of the day, diode is just this little component. If the voltage in the reverse direction is super high, it can break it, right? So at one point it can break down the voltage. So it's like a one-way street that someone who is very important or who is very powerful, who is very high ranked, they enter the one-way street from the other direction. So it's like this: if the voltage is too high, the power is so it will break the diode. This point, we call it VZK. Z is for it's an acronym for Zener. K is for Ni, Zener Ni. I'll tell you more about Zener Diodes. But for now, keep it in your mind that if the voltage was less than minus VZK, it will break the voltage and will go to the breakdown region. What did I want to tell you about the Zener diodes? Look, a normal diode that you buy maybe for 10 12 from the store. These diodes, when they go to the breakdown voltage, they are burnt. You cannot use them anymore. They are broken. But there are some diodes called Zener diodes that they still work. They actually have two different levels of operation. In forward bias, they will have a 0.7 the voltage drop, and then they work like an open circuit. And in the Zener mode or in the breakdown region, they might have like a 10 volts or 20 volts or 5 volts, depends of the voltage drop, and then they start to work. Actually, they can be very useful, especially in voltage regulators and these things. Zener diode can be a pretty useful thing. So for now, just remember these three regions: forward bias, reverse bias, breakdown bias. And I'm just gonna simplify it for you. This thing only conducts when we are moving towards the direction, towards the arrow direction. Against that, it's not gonna work unless the power is too high. The reverse voltage is too high. This is in simple words. And when we are having it in the right direction, we will have a 0.7 voltage drop there. Now, if you want to model your diode in the forward characteristic, it means if imagine that you are working in the normal mode and your current is going towards the arrow direction. How do you model it now? In the ideal diode, if you remember, when it was in forward biased, we were modeling it with a wire, right? And when it was in the reverse bias, we were modeling it with an open circuit. But here, we just learned something. We learned that there is going to be a little bit of a voltage drop here. There's going to be a 0.7 or in some cases 0.3 or something, right? So if you want to find I, for example, in this case, your I will be VDD minus this VD, which is like 0.7 over R. So it's not going to work completely as a wire. It's going to work somehow like a battery in the opposite direction, right? Because it's going to have a 0.7 voltage drop. So this is the best model that you can use for a diode in forward bias region. You're going to model it with a little battery. When in this case, the value of this battery is 0.7. Look, it's going to, before in your ideal diode case, this graph was starting at 0 because we were assuming that there is no voltage drop on diodes for ideal diodes. Here we know that there is a 0.7 drop here. So basically we're gonna have a battery over here to model the presence of the diode. So if we go back to this circuit, we can replace this diode here with a battery with the value of VD, which is 0.7, and then this equation to find ID is still intact. So maybe the best case to generalize the idea to model this realistic diode in a circuit is to replace it with a battery, a 0.7 battery, and an ideal diode. Why did I put the ideal diode here? Because this ideal diode makes sure that only the currents which are going towards the direction can pass, and this battery takes care of that 0.7 voltage drop that occurs in realistic diode. So look, it's a realistic diode that you can buy it from the store. In this realistic diode, there is a 0.7 voltage drop, and also we know that it's only passing the voltage only in one direction, passing the current only in one direction. So we will model an ideal diode. Ideal diode is something that only it's like a one-way sign without any voltage drop, and a 0.7 battery in the reverse direction that makes sure that your signal will have a drop of 0.7 volts. So thank you very much for watching, and please come up with your questions to the next class. I will send you more examples in the next videos. Have fun, take care, and see you soon.